Okay, a student has asked me to solve this problem that they were stuck on, so I'm making this video. Hopefully all can benefit. So on fundamental theorem of algebra, we learned something under that umbrella called the conjugate root theorem, which states that if we have a complex zero, like negative 6i, then by necessity positive 6i will also be a zero of this polynomial. So given that, we can construct a polynomial, a quadratic, that will divide into f of x. So if negative 6i is a 0, then by necessity, x plus 6i is a factor of my polynomial. And if 6i is a 0, then x minus 6i is a factor of my polynomial. If I go ahead and distribute all of my terms, I will come out with the following quadratic. First, I see that the middle terms are going to sum to 0. And then I notice that I have x squared minus 36i squared remaining. Now, as a side note, I squared is negative 1 and the square root squared, which means it's just negative 1. So I have x squared minus 36 times negative 1, which is x squared plus 36. So now I know that f of x should divide very nicely by x squared plus 36. So now we do some division. So inside the division, I'm going to have my full polynomial f of x. Actually, let's put it down here and give ourselves a little bit more space. So we have x to the 4th minus 15x cubed plus 90x squared minus 540x plus 1944. Let's go ahead and put x squared plus 36 as the divisor, and let's find our quotient. So x to the 4th divided by x squared, I have x squared. Multiplying back, I have x to the 4th plus 36x squared. Now I'm going to put it here, right, to match up my terms. Next I'm going to subtract. So because I'm subtracting, this is going to become a negative here, or combine with a minus. Here's also a negative, and let's combine our terms. We now have left no x to the 4th terms. We have negative 15x to the 3rd plus a 54x squared. We're going to bring down that minus 540x, and we recycle this process of divide, multiply, subtract. You can even sing a song if you want. I won't. Divide negative 15x to the 3rd divided by x squared gives me minus 15x, right? Let's multiply that right back and see what we get. Negative 15x times x squared gives me minus 15x cubed, and then times the 36 is going to be negative 540x, which we'll put right here. Then we're going to sum up our terms. Now remember, because we're subtracting, this is right here is going to turn into a positive. This will also turn into a positive. Again, our terms here sum up to 0, so we have left positive 54x squared. Oops, let's put that in red. Positive 54x squared. And then these terms also sum up to 0, so now I can bring down my plus 1944. Now let's see what happens. 54x squared divided by x squared will give me a positive 54. Multiplying back, I have 54x squared, and what do you think 54 times 36 is? None other than 1944. Now currently that's a positive, but when we go to subtract our terms, check it out, we have a remainder of 0. And that's exactly what we expected. So now what we can say is our polynomial f of x, let's go back to red, we know for sure that it can factor into x squared plus 36 times x squared, our quotient, minus 15x plus 54. Now, it's very decent of the textbook to give you a trinomial that's going to factor. We can write x squared plus 36 as x minus 6i and x plus 6i. And we can write x squared minus 15x plus 54 as x minus 9 and x minus 6, because negative 9 times negative 6 will give me positive 54. If x times x will give me x squared, and if I continue to multiply, x times negative 6 will give me negative 6x, negative 9 times x, negative 9x. That gives me this x squared minus 15x plus 54. And now, If I take a look, nothing else can be factored, so I am ready to submit my answer.